And what time is it again? It is hands up, hands up, hands up time! And I haven't taught in like 36 hours, so it's like, I got a lot to like, make up for. So today, I got the tape, and I need to stop clapping. I promised myself I'd stop doing that. We have 2 more days in the week. We're gonna go with the black marker for this one and the green one for next time. Hopefully you have your tools. I have my tools. I have my photo math right here. I got my black marker and I have time to mess with it tonight. So here is my cap that I thought about it ahead of time. It is now getting thrown in the other room, which I'll have to find later. We are on Math Minute 62. Super excited about it. But I moved it down a little bit tonight, so it's a little bit more straight on. So we're gonna see if that works too. I think by the time the end of May comes around, Math Minutes may actually be able to be seen regularly, like on a small phone instead of just having to blow it up on your TV. Let's take this stuff down. See how many I can fit on here? I got 5. Yeah, I think. Nope, just 5. 6 is just gonna have to go away. Sorry, 6. There we go. So, number 1, 13,328.96. Which digit is in the 100th place? Just so, 13,328.96. That's the number we have to figure things out with. And which one are we looking for? We are looking for 100. No, 100th. That's which one we're using. See this TH on the end? When we see the TH, that means that we are not on this side of the decimal point, not on the whole numbers. We are on the other side. And since I do have the green marker right here, I'll show you exactly where that's at. You see this part right here? The TH, when you see the TH, that means it's on this side of the decimal point. It's on the right side. So when we look at this number, we have 10,000s, thousands, hundreds, tens, ones. Then we have decimal point. We skip over, we go tenths, hundredths. So what digit's in that place? It's definitely not the 1. It's not the 3. It's not the 3. It's not the 8. It's not the 2. Because that's all on this side, so that's all garbage. So we don't have to worry about that. It's either one of those, and we already know. This is tens. This is hundreds. The number is 6. Excellent for us. Number 2, circle the answer that is equal to v to the 6th power. Ooh, we got this. We got this. Even though this is a variable, this is still our base when we're looking at exponents. So our base is what will repeat, right? Base, 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 base. So that looks pretty good. How many times is the base going to be repeated? This number, in case you can't see it, is v to the 6th power. Is this v to the 6th power? There's a secret to this one. What's wrong with this? Let's count them first. We have 1v, 2, 3, 4, 5, 6. Fine, we're done, right? Done, done. No, we're not done. Because this doesn't mean plus. This base is how many times we times that number by. So is this a plus? So that is wrong. 6 times v. Does that seem right? I don't know. So we know it can't be A. B, it's 6 times V. I don't think it looks like that. Have we ever written an exponent like that? Let's keep looking. V to the 3rd power plus V to the 3rd power. I don't know. Let's think about that last one, because this last one kind of looks more like what we've talked about in the past. We have V times V times V times V times V times V. So let's look at that. So 6 to the V to the 6th power. So 1, 2, 3, 4, 5, 6. And I wouldn't write on it because that's my wall over here, by the way. Wall, so I can't do it. And there's 6 V's. and the base is V. So which is my answer? D, of course. Okay, this one I can understand why you thought it was this one. And I kind of understood if you thought it was that one. But technically the answer is D. Because this is how you would write it out if you're writing it out. The base is V and the exponent is 6. 1, 2, 3, 4, 5, 6. There you go. Number 3, what is the temperature? Oh, you got this. You got this. Here's the gauge. This is the number where you're looking at. So what number is that? This is 50. This is 45. This is 40. As you can see, you're like, it's only halfway in between. So which one is it? Is it going to be 50 degrees? No. Is it going to be 45 degrees? No. Where does the dark spot end? At 40 degrees. Right there. That one was easy. That one was too easy. That might be a little bit even too easy for us. So number 4, what is the square root of 25? First thing we're going to do is the first time today that we're going to be using our tool. So hopefully you have your tool next to you as well. So I'm going to take my tool and I'm going to go the square root of 25. My tool says it's 5. What's another way to check it? We got to ask our girl. Alexa, what is the square root of 25?
The square root of 25 is 5.
Excellent. Alexa, thank you, my friend.
Anytime, Laura.
All right, so.
Hope you've had a good Wednesday.
I have, thank you. So we know from Alexa that it's 5. We know from PhotoMath that it's 5. But how do we know that it's 5? Because this square root button means the number times itself equals this number inside the bracket. So 1 times 1, we can just do it the old-fashioned way. 1 times 1, 1. 2 times 2, 4. 3 times 3, 9. And I'm doing this out of my head. That's why you got to keep practicing your times tables. 4 times 4, 16. 5 times 5 equals 25. And as you can see, now you can actually see it, is that it can't be this because that last number has to equal this one side. They told us it was this, and we know that if we were going to write this number like we did up here, the base would be 5, right? And how many times do we repeat it? 2. You see how all this ties together? Because math is like that. It ties and like intertwines, and if you understand one concept, then you can kind of get the other concept just by noticing the symbols. So, number 5. If 100 equals 10 to the k power, then k equals what? How do we figure this one out? So let's listen to it one more time. First off, I'm going to put down over here so it's bigger. If 100 equals 10 to the k power, then k equals what? Again, 2 ways to do it. And there's probably a ton of ways to do it. We're going to do 2 of them tonight, though. We're going to do it the tool way, and we're going to do it the Corona way. The tool way is we go over here to our PhotoMath, and we do 100 equals 10 to the k power. Gotta find that power button. So when I find that, it tells me that k is supposed to be 2. But let's go back to the Corona way of doing this. So we know that this is the base, right? So here's our base. That k is asking you how many times that number's repeated. Can we just do this again until we get to it? Yeah, of course we can. So 10 times 10 equals, because this is what they say the answer is, but 10 times 10 is, get your tool out. You should be following along with me too, by the way. We had talked about this a lot, and I called everybody's parents in my program. I called you yesterday. So 10 times 10 equals 100. That's how they got to be 10K, K equals 2. Because what they did was is they said, how many times am I going to repeat that 10? Only 2. Because if I did it 3, that would be 1,000. And you know how I did that so fast in my head? Look at the pattern. So when you times things when you're timesing tens, like a base of 10, all you do, just like you're dividing and moving decimal points, in this one, you count the zeros. So you got 2 zeros. You got 1 0, you got 2 zeros. So all you gotta do is put your 2 zeros down and then just drop off the 1. And you got it. And that's how I know this can work again. Watch. How many zeros I got? 1, 2, 3. So I put 3 zeros down. And then I just pull over my 1. That's how you do that fast. That's how you do it fast. That's how you do it in your head. We're not super geniuses, us people that do math. We find a system and it works for us. All right. So how do you think so far? I'm thinking good. Woo. And we're gonna go with my other system. And my other system is flipping this upside down now instead of playing around with the folding of it. Because when I started folding it, not only did it take me forever, and I'm trying to get these videos down in size because I've noticed that I've had you guys watch about 2 hours of videos, like almost every day or every other day. So I'm trying to be a little better. All right. So we put this here, and then we gotta mess with, there we go. Perfect. Then we gotta mess with the computer here. Oh, I didn't get all of them. Yeah, good for me. Woo! Got it. Number 6. All right, number 6. They're trying to because there've been so much exponents involved in this. They're trying to give you an easy one. 10 over 2. I don't know why I stuttered over that. I'm sorry. 10 divided by 2. Because this may look like a fraction, but this is all this looks like. That's literally it. So the Corona way, oh no, let's do it the tool way first. The tool way is 10 divided by 2. Answer is 5 when I do it on my tool. But just so you can see it, you take how many parts you have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So those are how that is all the parts you have. You have 10 parts. Then how many groups do you put them in? And you put them in groups of 2. So ready? 1 group, 2 groups, 3 groups, 4 groups, 5 groups. So there's your 5 groups. The Corona way, the tool way. Get your same answer, works out. That's why math is awesome. We were just talking about it. We just talked about it and I didn't look ahead of time because I can handle this math. Number 7, 3.38 times 100. Just so you guys can see it a little better. 3.38 times 100 equals. We can do this. Let's do it on our tool first, and then let's understand it. So we have 3.38 times 100. And like I said, you should be doing these calculations with me. So the solution is, sorry, 338. Sorry, I got a, I got an ad on my calculator. Okay, so that is what photo math says it was for me, okay? But let's do it the coronavirus way. Let's take our time. It's like a vintage cheese. It's smelly, but it tastes weird and awesome and all its own little funkiness. How many zeros do I have? Because remember, anytime you're timesing or dividing by 100, you can do it this way. So you have 1 0, 2 zeros. So since we're timesing, we're going to go that way. If we were dividing, we would go that way. So how many times am I going to move the decimal point? So here's the decimal point right there. I'm going to move it once. I'm going to move it twice. And guess what? Exactly the same answer. 338. and 38. Excellent for us. Number 8. What is the sum of 200 and 400? Oh, they're making you use your reading. What is the sum of 200 and 400? So let's put those numbers down. 200 and 400. We everybody in here knows how to do, like, write those numbers down. I got you. What is a sum? Who can we ask for that? Say we didn't know. Say we don't know what that vocabulary word means. That math, yes, because math has vocabulary. What does that mean? And I did put a little heart around it because sum is amazing. I think we should ask her. Let's ask her. Alexa, what does the word sum mean in math?
This might answer your question. In mathematics, summation is the addition of a sequence of any kind of numbers.
Alexa, thank you.
Add-ins or summons. The result is
Alexa,
the sum
stop.
total.
Sometimes she tells me just a little bit too much of what I want to know. I feel that that's the way you guys feel about me, so that keeps me humble. Sum means, you heard it, addition. So that was the sum. So what am I going to put in between these two numbers? Plus. That's it. So we're going to take our tool out. We're going to do it the Corona way. We'll do it the tool way and then do it the Corona way. So 200 plus, you should be doing it, plus 400 equals 600. So our tool tells us it's 600. But how do we do it the Corona way? So when you do it the Corona way, you got to line up the problem. Okay, so that's first and foremost. So you got to line it up. So you got to do, so there it is. And then you line this one up. Ooh, I put that instead. Celebrate our mistake. Let's try again. 200 plus 400. 0 plus 0, 0. I'll make that answer down here. 0 plus 0, 0. And 4 plus 2. So you got 4. 2 more. That's it. 6. We got the Corona way and our tool way. Both comes out the same. That's why it's always important to check your work, guys. Check your work. Take the extra 5 seconds out of your lives. You won't regret it. Number 9. What is the smallest 2-digit prime number? Okay, let's use our tools first, and then we're going to try to figure it out longhand. See if we can reinvent the wheel together. Alexa, can you please tell me the prime numbers in order?
Here's something I found on the web. According to Jiska.com, order -3, 5, 16, and -10 from least to greatest.
I have no idea what she's talking about. Let's try this again. Alexa, can you tell me prime numbers, please?
Prime numbers is a plural form of prime number. Prime number is usually defined as an integer that has no integral factors but itself in one.
Alexa, can you list prime numbers, please?
Prime numbers include 3, 5, 7, Pythagoras prime, and 19. To see more, check out the Alexa app.
She's trolling me tonight. She is trolling me tonight. She gave me almost all of them up to the number I'm actually looking for. Because remember, prime numbers are 3, technically 1, but that's neither here nor there. 1, 3, 5, 7, and then the next one was our answer. Ah! Okay, so let's make her really work. Alexa, is 8 a prime number?
No, 8 is not a prime number.
Alexa, is 9 a prime number?
No, 9 is not a prime number.
Alexa, is 10 a prime number?
No, 10 is not a prime number.
Alexa, is 11 a prime number?
Yes,
Woo!
11 is a prime number.
There we go. Look what I was trying to find. What is the smallest 2-digit prime number. Okay, so 10 was the first 2-digit number altogether, and 11 was the first prime 2-digit number. Okay, so that was like pulling teeth. And sometimes when we use our tech tools, it is kind of like that because you have to be able to use the proper question. I've seen you guys Google. I've seen you struggle to Google. It's okay. We got this. So we know that the answer is technically 11 after literally torturing Alexa trying to get it out. Boy, she didn't even recognize that tonight. Whew, she's in a mood. So we know that. But talking about prime numbers, it helped out in this situation, but let's go look down here. So why I could figure it out and I could know it even if she had a hard time giving it to me. 1 is a prime number because 1 times 1 is 1, but there's no other 2 whole numbers that you can make to get 1. 3, you can't times 2 numbers together to get 3, so not that one. 5 is a prime number. You can't times 2 numbers to get that. 7, same. But then we started doing the, is this it? Is this it? Is this it? No. If you look at a multiplication chart, you can find 2 or 3 ways to get 8. You can go ahead and I think there's one way to get 9. There's multiple ways to get 10. 11, you can't get that either. So whenever you're looking for prime numbers, you're looking for numbers that can't be divided by any other numbers but just 1. It's it. It's it. Do it like that too. Here you go. Prime numbers is tough. Sometimes you just gotta know them. So forget all this stuff down here. Done. We have parentheses 2, parentheses 3, parentheses 4, close parentheses equals what? You can definitely do this on your tool. There's no doubt about it. Okay, if you want to sit here for pretty much forever and get in all those parentheses marks, you could do that. But next time you see this, and it's just parentheses in between, those are telling you the numbers are right up against each other. And we've already figured this out a long time ago. When things are pressed up against each other and there's no symbol in between, that's times. Times. Since I don't want to sit here for another 9 years, and God knows how long this video is already, we have 2 times 3 times 4 equals. It's the same concept, but just so you guys can see it in case, because like I said, it's kind of iffy sometimes. Do you see that? This is the same as this. These parentheses, without them, those numbers would be squished together and we would have no idea how to read them. So you have to have the parentheses in there. Even though it seems like it's complicated, it's really not. This just means times. So I take my times down here and all I do is, I do my tool first. 2 times 3 times 4. Our answer is 24. But how do we make sure that that's correct? How do we do that? Well, I know sometimes we struggle, and there's nothing wrong with it. We kind of get a little overwhelmed. So what you do is you do it the first part first. So we're going to do this part first. So 2 times 3. Okay, skip count. Let's just go ahead and take it all the way to the fundamentals. 2, 4, 6. So the first part is 6. Okay? So then 6 times 4. We do the second part. All we do is drop that 4 down. We put the 6 here. We just make a new problem. It's not a big deal. We make new problems all the time. The actual numbers, the calculations and the measurements are still the same. It's just in a different form. It's okay. Math, you're allowed to do that. 6 times 4. Skip counting in 4s is tough. So Miss Cheer is going to do it real fast for you, okay? But you should do this on your calculator to make sure you're correct. But 6 times 1 is 6. 6 times 2 is 12. 6 times 3 is 18. 6 times 4 is 24. All right, we didn't have any monsters today. Didn't have to draw any monsters. I'm gonna have to go find my pen cap in a second. You guys did a good job on this one. This whole paper is all filled up. We went a little bit extra, not super extra, just a little extra today. And I hope you have a beautiful evening. Thank you for coming to Midnight Math. And I'll see you guys tomorrow. Stay safe, stay healthy.